1. All right. So right here, I listed the 4, I would say, big ideas of this test, okay? Let's talk about the first big idea, which is graphing inequalities. So when you graph inequalities, x is greater than or equal to 3. Guys, I'm probably going to have the number line for you, but you have the number line 3, and keep in mind where 0 is. Since 0's on the left, what I do is I plug in 0 into here. When I see 0's not bigger than 3, I see that's false. Guys, I'm not planning to talk over you. I'll stop the video. I just make everyone review. Stop talking. Gabe, I will stop the video. Guys, Wall sits later. Sit down normally. Whatever. So, in this case, it's false. So there's 2 parts. First off, remember, if it's less than or greater than, you're going to do an open circle. When it's less than or equal to or greater than or equal to, you're going to do a closed circle. So with this in mind, since it's greater than or equal to, closed circle. And then since it's false, I go away from 0. Since 0's on the left, I tend to go to the right. When it comes to solving inequalities, it's the same thing as equations. There's just one rule that you have to maintain, okay? So let's say x plus 3 is less than 10, minus 3 minus 3. Nothing changes really. Still x is less than 7. It's just like solving an equation. Graphing's still the same. I put 7 here. I keep in my mind that 0's on the left side. 0's less than 7. Oh, that is true. So since that's true, I do an open circle because it's less than, and color towards the truth, which happens to be the left in this case. The one rule you do need to remember is when you divide or multiply by a negative, it's greater than or equal to 4. When you divide or multiply by a negative, you have to flip the sign. So in this case, I'm timesing -2 on both sides, or multiplying by -2 on both sides. So I end up getting x is greater than or equal to -8. But it's not going to be greater than or equal to. You have to flip the sign. So it's going to be less than or equal to -8. From there, you graph -8. Keep in mind, 0 is on the right side. So it's going to be I plug in 0 here. 0 is not smaller than 8. That's false. So I'm going to put a closed circle and go away from 0. Put a closed circle, go away from 0. Just like I said, they're still the same thing like equations. So even if I have multiple variables, so let's say 4x plus 3 is greater than or equal to 2x plus 1. In this scenario, I subtract the 2x's to both sides because I want to move the smallest x. That's what I always suggest. So 2x plus 3 is greater than or equal to 1. Minus 3 minus 3. 2x is greater than or equal to -2. Notice here, one of you could. One or the other. Pick. Then you could divide both sides by 2. Now, very important, in this scenario, even though I'm dividing, this number is -2, the thing I'm dividing by is not negative, which means I do not flip it. So x is greater than or equal to -1. -1 in the middle. 0's bigger than -1. 0 is greater than or equal to -1. That's true. So closed circle, go to the right. There are compound inequalities. So for example, a compound inequality could be an or statement or an and statement. So an or statement like, Let's get this one. 3x plus 2 is less than 8, or negative x plus 3 is less than negative 2. In this scenario, you're just solving each one separately and graphing them together. Because it's an or statement, you should know your final result should look like they're going opposite directions. It's one way or the other. So that's why it's an or statement. Goes together. This and that goes together. You go this way or that way. You can't go this way and that way, or yeah. So you solve each one separately. Minus 2, minus 2. 3x is less than 6. Divided by 3, divided by 3. X is less than 2. So that's my first one. Minus 3, minus 3. Negative x is less than negative 5. Please don't be freaked out if you have a negative x. That's the same thing. Shh, guys, volume went up. Be quiet. Shh. We're going to put negative 1 here. So I'm dividing by negative 1 on both sides. Because I'm dividing by negative 1, that's going to flip the sign. So x is bigger than 5. So on my number line, I put 2, I put 5. I should note where 0 is. 0 happens to be over here. 2 is less than x, or I'm sorry, x is less than 2. So x, when it comes to 0, 0 is less than 2. I go towards 0. 0 is less than 2. That's true. In this one, if I plug in 0 bigger than 5, that's false or not true. So I'm going to do an open circle going this way.
Every time, like, the number is bigger than 0, you go this way, like, away from 0?
If it's a true statement, so like 0 being smaller than true, you go towards 0. If it's a fake or false statement, 0 bigger than 5, that's not true.
Is 0 always going to be like here?
It depends, because if I had a number line just for the video, the question is, will 0 always be on the left? Not necessarily. What if I had something like negative 2 and 6? In this case, 0 would be in the middle.
But wait, because I don't know, like, when to, like, I'm confused with the arrows thing. Like, I don't know.
So that's why I say you always plug it in. So I look at x, I make it a 0. And since this is false, I look at where 0 is, which is over here. And I don't want to go to the false, right? So I go away from it. That's why I go.
Or is it always, they're always going to end up going like this way?
Yes, if you do it right, it should look like that.
Okay, so I'll do that.
Yeah. All right. The other compound inequality is the and statement. You're going to see it on your worksheet like this. You'll see it on your worksheets like this. Let's do this one. 0 is less than or equal to 2 times x minus 3, which is less than 8. This is an and statement. Because it is an and statement, you should know they go into each other. So it's an and statement. It's going to be like a line segment. So you're going to need to split this up. Please split it up first before you do any math. So my first split is 0 is less than or equal to 2 times x minus 3. Do not be the person that makes this mistake. That happens every year. When you split the other side, you take the whole middle with you. So it's going to be 2x minus 3. You repeat the middle as is less than 8. Some reason, every year, someone will just do like split this part off or something like that. Don't be that person this year. So you still solve them separately. 2x, I'm distributing, 2x and negative 3. So 2x negative 6 plus 6 on both sides. 6 is less than or equal to 2x, divided by 2 on both sides. 3 is less than or equal to x. Over here in orange, distribute the 2. 2x minus 6 is less than 8. Plus 6 plus 6. 2x is less than 14. Divided by 2, divided by 2. I'm dividing by a positive number, so there's no flipping. X is divided by 7. So when I make my number line, 3, 7. In this case, 0 happens to be smaller than both of them, so I put it on the left. 3 is less than or equal to 0. Well, that's not true. So I'm going to the right over here. Close circle to the right. And then this one over here, 0 is less than 7. That is true, so 7 is going towards 0. So open circle, 0 this way. It meets in the middle. This is still in section 1. I should have put a 1 here. Okay. The second thing I'm testing you on in general is going to be translating verbal phrases. There's a bunch of these on the worksheet, so make sure you practice it. But if I say something like this, I'll type it out. The sum of 15 and n is less than 8. And I'll do another one. 15 is no more than x. So first one here, you need to know your key operation words. Sum is usually adding. Difference is subtraction. Product is multiplication. Quotient is division. Know those. So 15 and n is less than 8. So 15 plus n is less than, so smaller than 8. So you're just going to translate the phrase. On the worksheet here, they make you also graph it. I will not make you graph it at the same time. I'll just ask you to translate it. This one, 15 is no more than x. So be careful. If it's no more, I cannot be above 15. So 15 is no more than x. 15 cannot be bigger than x. So 15 is less than or equal to x. 15 cannot be bigger than x. So it must be 15 is less than or equal to x. There's a bunch of translating in the practice worksheets. All right, section 3 was about the absolute value. When it comes to absolute value, keep in mind, you're just splitting because you could get the positive answer and negative answer. So you would do x equals 9 and x equals, in this case, negative 9. This one's a straightforward one because it's just x equals. If you have an equation, you actually have to do the work. So for example, 2x minus 3 equals 15. We're going to split into two things. 2x minus 3 is equal to 15. And 2x minus 3 is equal to negative 15. Plus 3 plus 3. 2x equals 18. Divided by 2, divided by 2. X equals 9. Plus 3 plus 3. 2x is negative 12. Divided by 2, divided by 2. X is negative 6. So please make sure you do the work and just don't do the positive one and then make it, 9. It must be negative 9. Don't be that guy. That doesn't happen every year, but I don't want to happen to this year either. When it's an equation, you just do positive and negative. You don't have to think about anything. But when it's an inequality, you have to keep in mind something. So let's say absolute value is greater than or equal to 5. Keep in mind, it's going to be x is greater than or equal to 5. So you split it up. X is greater than or equal to 5. And when you do the negative one, you also have to flip it. X is less than or equal to negative 5. So make sure when you do the negative one, you flip the symbol. Here's 5. Here's negative 5. In this scenario, 0's in the middle. 0 bigger than or equal to 5? Well, that's not true. So we're going to go away from it. 0 is less than or equal to negative 5. Well, that's not true. We go away from it. This looks like an OR statement. When it comes to absolute value inequalities, it's going to look like an AND or an OR statement. Yeah. Absolute value. 3x minus 2 is less than or equal to 7. When you split it, remember you're flipping the sign. 3x minus 2 is less than or equal to 7. And 3x minus 2 is greater than or equal to 7, negative 7. You still solve it both ways. Plus 2 plus 2. 3x equals 9. Divided by, or is less than or equal to 9. Divide by 3, divide by 3. X is less than or equal to 3. Plus 2 plus 2. 3x is greater than or equal to negative 5. Divided by 3, divided by 3. X is less than or equal to negative 5 over 3. If you want it as a decimal to graph it a little better, 1.6 repeating. I will purposely not give you decimals, so don't worry about decimals, okay? X is greater than that. All right. Keep in mind in absolute value equations, before you split it, you must get the absolute value by itself. So in this scenario that I just drew up, you divide both sides by 3 first. Then is absolute value 2x plus 1 equals 4. Lower the volume a little bit. So then you split 2x plus 1 equals 4. 2x plus 1 equals negative 4. It does not matter if it's an equal sign or an inequality. Make sure your absolute value is by itself first before you graph or before you answer. 2x equals 3. X equals 3 over 2. Minus 1, minus 1. 2x equals negative 5. X equals negative 5 over 2. Again, these are fractions slash decimals. Not going to happen on your test. Don't sweat too much about that. The last thing is graphing the inequalities. I'm going to give you, so on the paper, there's two parts. One is plug in the solutions, and then the second page is like actually graphing. So when you test the solutions, if I give you something like this, 5x plus 2y is less than or equal to 8, and it's negative 3 comma 6. Remember, it's always x comma y. So I'm going to take the x and plug it with negative 3, and take the y and plug it in 6. So 5 times negative 3 plus 2 times 6 is less than or equal to 8. Negative 15 plus 12 is less than or equal to 8. Negative 3 is less than or equal to 8. This is a true statement. So in these situations, you tell me, does it make a solution or not? You can say yes or no, or true or false. I don't really care. The other thing we're doing is actually graphing. So let's say y is greater than or equal to 2x minus 1. Oh, whatever. So in this scenario, in this scenario, remember your m is your slope, so 2 over 1. Your b is your y-intercept, that's -1. So I'm going to start 1 down. And since my slope is 2 over 1, that's up and right or down and left. So up 2, right 1, down 2, left 1. Make sure to connect the dots. Now, here's the last thing. In this section, you need to figure out where you're shading. Guys, one more time. I'm almost done. I'm going to pick a point to plug in. Usually I plug in 0, 0, but you can plug in any point that's not on the straight line. So I take 0, 0 and plug it into the equation here. 0 is greater than or equal to 2 times 0 minus 1. 0 is greater than or equal to -1. That is a true statement. 0 is bigger than -1. Since it's a true statement, I shade this way. And I shade up. Shade down. Good. If it happened to be false, I'll do this for video. If it happened to be false, you shade away, okay? In this particular scenario, it was true, so we go shade up. Keep in mind, you could get vertical lines up straight up or horizontal lines sideways. I don't think that shows up on the practice. Keep that in mind, though. That is available. But it was on your homework, so it should not be a surprise. Use this to help you. Your test is next week.